Okay, I think we ended here last time, dun sa last lecture. Itutuloy ko lang. Again, we're now covering yung Garnet Zone. And basically, ito yung alternative scenario kung paano nag-form yung garnet in some iron-rich depletic sediments. So, chloritoid plus biotite, tile flip, punta sa garnet plus chlorite, and then the iron-rich ones are now exposed to the garnet, chlorite, chloritoid, chlorite triangle, and at the same time, garnet, chlorite, biotite triangle. So, as you can see from here, the first appearance or final disappearance of the mineral rarely reflects yung absolute stability limits of that mineral, but in general, instead, it reflects yung overall stability range. Okay, I think we've discussed this before. But to highlight more kung ano nangyayari dito, so garnet zone garnet zone, note that the reaction does not add any new phase in the AFM diagram. However, yung tile line flips makes some minerals available to these pelitic sediments, for example. Okay? I think natapos ko pala tong part na to. Yan. And I think, yeah, most pelites in 2 and 4. Wait lang nga. Okay. Upon checking, wala. Naka-move on na pala tayo dito matagal na. Storolite zone, even this one I already did. And balikan nyo na lang yung ano. So, ito pala dapat start here for part 2. So, we now go to pseudo sections. So this from the previous reactions that we've seen, I hope by now na realize niyo na kung gaano ka-important yung pseudo sections in the sense that it actually shows to us yung actual reactions na mangyayari din sa bato natin and not just ano yung general lahat ng possible reactions. So review na for discontinuous reactions, F equals 0, meaning the reaction must run to completion before moving again sa PT space versus a continuous reaction wherein you can move across the PT space and both or the products and the results the reactants and the products can coexist, and this results to high degree they can continue coexisting at the same time and nagko-continue na sila sa PT space. Pero syempre, kumukonti yung reactants natin and dumadami na dumadami yung products. Okay? Another implication ng continuous reaction is that it has a fewer phases, and in general, this results to higher degree of freedom and variance. So sa PT grids, the PT grids show phase relations for all possible compositions representing univariant reaction curves and invariant reaction. The strength of these PT grids is that they constrain the stability of a phase irrespective of the bulk X. However, as we've seen, several assemblages may be stable within any given region of the diagram depending on bulk X. That is, only a small subset will actually depict these reactions, and high variance of continuous reactions limit phase stabilities. I think gets niyo pa naman tong yung strength basically na pseudo section versus PT grid. Okay? And high variance of continuous reactions limits phase stabilities. Sige. Okay. I think yung point nitong last statement, only a subset gets yon. High variance of continuous reactions limits phase stabilities. Meaning, actually, hindi siya, yung, as we've seen before, the chloride, the minerals can actually stay stable. For example, yung chloride natin, stable lang siya. So, present siya sa sample natin all throughout. Yes, umiiksi yung chloride na field. So, kumukonti yung chloride. Pero, through continuous reaction, andun pa rin yung chloride, basically. Okay? Yan. So, pseudosections and high variance reactions in KFMASH versus grid projections, only one PTX state is represented so that at each point X and proportion of the phases and thermodynamic properties are uniquely determined, we can produce therefore a PT or a TX or a PX diagram where X is a composition. So here, for example, is a TX diagram. So T versus magnesium number. And each, as you can see from here, each field is labeled with a mineral assemblage stable within that PT space. Okay? Sa pseudo sections, usually colored sila, grayscale. And basically, when reading this, higher variants are shaded darker. Higher variants meaning less faces. So as you can see from here, for example, dalawa lang yung face. So this field of two face versus itong three faces. So mas marami yung andito mas lighter yung shade nito. Three faces. Okay? Pure iron, as we've tackled before, pag pure iron or pure magnesium yung bato nyo, in this case, the reactions uh, run to completion discontinuously. Meaning, dito, for example, yung iron chloride to form almandine and anite, the iron biotite, then hindi siya makaka-move forward yung conversion ng chloride to almandine plus anite, hindi siya mag-move forward sa sa temperature, sa T space until maubos lahat ng chloride, and then finally doon lang magfo-form yung almandine. At doon lang mag-move forward ulit yung temperature. And in contrast to that, yung ating reaction, for example, if yung X natin is here, then yung reaction can proceed sa PT space na yung reactant, chlorite and biotite, still coexists with the product garnet, for example. Okay? Yan. So, pure iron or magnesium end reactions are magnesium end members pala. In those areas, the reactions are discontinuous, pero within the KFMASH reaction is continuous since the number of component increases while the number of phases remains. Okay? Yeah, so let's look at scenarios. Continuous reaction. So example number 1, if magnesium 10, for example, yung ating bato, so dito siya sa AFM diagram natin. Yan. So if i-follow lang natin siya, roughly, pagdating dito sa increase lang yung temperature basically, and you have basically initially chloride plus biotite. Okay? Upon entering itong point na to, then the chloride starts to move away, mas magiging magnesium siya. And at the same time, it now enters yung chloride biotite garnet na field. So ito yung part na yun. Ito yung precise moment na kunwari, somewhere dito sa B, somewhere dito within this field, kunwari dito for example na temperature, dyan na nagsimula na kainin basically nitong tie line yung ating bulk composition 10. Yan. So dito na siya, nandito na siya, it now belongs to this triangle, garnet, chloride, and biotite. So sa pseudo section, ganito naman yung itsura niya, andito na siya sa field na to. Okay? Until eventually, hanggang sa macross niya yung 600. So pagdating sa 600, tie line flip. Okay? Dito sa diagram, tie line flip. Basically, so from garnet to chloride, magiging staurolite to biotite. So ito yon, staurolite to biotite. And yung atin namang bato would be garnet biotite, si bulk 10. So bakit walang staurolite? Kasi as you can see from here, chloride biotite to chloride biotite plus garnet to garnet biotite yung kanyang fields. Sa AFM diagram, yung 10 kasi natin, since masyado siyang iron-rich, yung next niya would be garnet and biotite na lang. So, as the reaction progresses, yung 10 natin, hindi na nagbago yung mineralogy niya, nananatili lang siyang garnet plus biotite kasi nandito na yung tie line niya. Okay? Tingnan naman natin yung bulk 20. Si 20, as you can see, same thing as si bulk XMG10. Ganun din, si bulk XMG20, start siya ng chloride and biotite. So, dito siya sa field na to, chloride biotite tie line. And then as the reaction progresses, again, lumiliit nga yung field ng chloride natin. And then, lumalaki yung field ng garnet until eventually, masisweep niya yung 20 natin. So, nandito na siya sa chloride biotite garnet. Okay? Parang yung kaninang case. Chloride biotite garnet. And then, if ituloy pa natin tong arrow na to, pupunta dito, it now encounters yung invariant curve, Storolite plus biotite, garnet plus chlorite. So, ito yung tie line flip sa sa dito sa sa pseudosection. Ganito yung itsura niya ng tie line flip. Sa AFM diagram, ganito yung itsura niya from a garnet chloride biotite na field magiging garnet biotite and storolite because of the tie line flip. So ganito dito na yun siya. Okay? Now let's look at magnesium XMG 30, let's say 35. So ganun din, chloride plus biotite, 35 start siya dito. Next ay pagdating dun sa tie line flip, pagdating niya dito, so magsisimula siya again ng chloride, biotite, garnet. So ito yung chloride, biotite, garnet. Dito pala, parang 30. Imagine niyo lang na magpasta kay 35. So nakita na natin si garnet, chloride. And then, once it enters itong, once it encounters itong invariant curve natin, again, ang magiging product niya daw, based dito sa pseudosection, would be chloride, biotite, and storolite. And sa AFM, ito yung itsura nun. You have storolite, chloride, and biotite. So, kaya siya in the first place. I mean, sa pseudosection, ganito yung itsura. Sa AFM diagram, ganito yung itsura niya. Okay? So on and so forth. Itong 45, for example, if we do the same thing, again, start the same way, pero hindi niya ma-encounter yung chloride, biotite, garnet na field. Instead, ang may encounter niya ay chloride, biotite, storolite kasi sobrang XMG niya na hindi na niya makikita basically itong sub-triangle na to. Ang makikita niya na lang is yung triangle na to na nag-move forward na. Okay? Yan. So, ganun yung representation ng pseudosection dito at saka dito at saka AFM diagram. So bakit siya, ito rin yung isang reason kung bakit siya tinatawag na pseudo-section. Meaning, hindi siya real PT grid in the sense na, di ba, kung phase diagram to, yung movement niya dapat is this way. Pa-follow niyo dapat yung curve. Pero ang concern natin is, since fixed yung magnesium number natin, since fixed yung bulk composition natin, then it just continues on. Okay? Hindi nagbabago yung XMG niya. Okay? So, continuous reaction, chloride plus muscovite plus quartz equals garnet plus biotite. A new phase is introduced at B, 585. Chloride is gradually consumed and garnet and biotite are produced. With increasing temperature, the magnesium number also increases, and depending on bulk X, can result to minerals being lost or formed. So, yun nga yung bulk 10 versus 20 versus 35 and 45. So, I suggest i-try nyo siya by yourself kung ano yung reactions or how the reactions progresses. Okay? This is not a again, so the sections are not a true section because the faces must be projected to it, hence the term pseudosection. This does not, however, detract from the ability of a pseudosection to accurately depict the proper phase assemblage at any P, T, and X bulk. Although the phase X and phase composition and their proportions by Lever rule cannot directly be determined from the pseudosection. So important yun na, take note na yung phase composition and proportions, hindi siya pwedeng gamitin na parang Lever rule. Okay, dito sa pseudosections. Ayan. So the position of chloride to the right of the loop A and of garnet to the left with biotite intermediate indicates that chloride is more magnesium rich than the associated biotite, which in turn is more magnesium rich than garnet when all 5 phases are in equilibrium. Sige. Anyway, I think yung important things ay natakal ko naman. Okay. Sige, next na lang muna tayo. So, compare nyo na lang si XMG 10 versus 20 nga. Yun yung ginawa natin kanina. Continuous reactions can cause a mineral, a biotite, garnet, or storolite to appear at grades above that at which the corresponding discontinuous reaction would take place as long as X or the bulk composition is appropriate. Sorry, wrong spelling. XMG developed new garnet, lost chloride over temperature difference of 585 to 600 due to continuous reaction only. XMG 20 at 610 discontinuous reaction and encounters the discontinuous reaction resulting to tie line flip. On the other hand, if ang bato mo, ang XMG ay 32 to 38, it loses garnet first. Yeah, I think we've tackled this before. So 35, for example, loses garnet first, and continuous reaction, chloride equals staurolite plus biotite till chloride equals 0. So wala nang chloride dito sa field D. Yan. Sa C35 na. Okay? Yeah. If XMG is equals to 45, new staurolite via same reaction, continuous reaction as migrating triangle. Loop B causes staurolite garnet biotite subtriangle to migrate towards the right. Towards the right. At temperatures greater than 610 degrees Celsius due to the reaction, biotite plus muscovite, biotite plus staurolite equals garnet. Yeah. If XMG, if bulk X is 45, new staurolite. Okay, yeah. New staurolite via same continuous loop. Anyway, ito lang. Yung point lang is yung C loop. Diba? Hindi siya magkaka-garnet in the first place. Okay. Yan. So, the figure is a pseudo-section. Is entirely fixed yung bulk niya. Sa KFMASH system, PTR independent. And magnesium number 40, for example, magnesium number at 40 shows the mineral assemblage fields only. Okay. I think yung point nito, ayan. So ito, kanina pinakita yung reaction. So nakaganto siya. I mean yung boundaries kagaya nito. Pero dito ang pinapakita niya lang is yung phase assemblages. Okay? So, consider following PT path in dash. Ito rin yung similar sa medium PT. Path begins as chloride only. But as temperature increases, garnet is included at 570. And then biotite also dito sa curve na to. And then chloride to end. So yung sequence is chloride only, chloride plus garnet dito, then chloride plus garnet plus biotite. Until eventually, wala nang chloride, magiging staurolite biotite na lang siya, staurolite garnet biotite, etc. So, ito yung diniscuss kanina. Ganyan. Ito, for example. So, yan daw ay bulk XMG 40. So, 40, ganun yung sequence niya. Chloride muna, chloride. Well, di na pinakita dito yung chloride only. Pero yan, chloride biotite, staurolite. Okay. Dito pala siya dapat. Kung 40. Okay. Yan, at 585, 0.75 GPa, path intersects univariant reaction. Garnet is consumed before chloride as staurolite is produced, and the path enters the chloride staurolite biotite field. Ito. Yan, tatawid lang siya. Further heating enters, the rock will enter the staurolite biotite field and then re-enters the system to enter and then garnet re-enters. So magdadagdag ulit ng garnet to enter the garnet staurolite biotite field. Di ba? Parang una, garnet is introduced, garnet is lost in favor of staurolite, and then chloride is lost in favor of staurolite plus biotite, and then garnet is gained ulit sa staurolite, garnet, and biotite. So basically, as you can see from these reactions, yung pelitic rocks natin, the minerals within the pelites can parang enter, exit, enter, exit, enter, exit. And hindi nyo maintindihan, hindi madaling ma-record easily, hindi easily ma-record kung ano yung, kung nasang sequence ka na, kung basis lang sa minerals. So instead, we use yung pseudo-sections to see kung ano yung theoretical reactions that are occurring sa bato natin. And at particular, PT grades. PT fields pala. Okay? So we can conclude from this, ito direct ano na lang, yung naka-highlight lang important. Medyo mahaba kasi yung sinabi ni Winter, pero yung naka-highlight at states that we can, from the lesson, we can conclude that the evolution of progressively metamorphosed pelites, or any rocks for that matter, is governed by a combination of discontinuous and continuous reactions. Continuous reactions affect affect the compositional ranges of solid solution minerals and occur over a range of temperature pressure conditions, causing virtually all of the subtriangles in the AF diagrams to migrate. So sa AFM, again, yung continuous reaction is just migration of the fields, of the tie lines, okay? Once a two-phase field shrinks to a single tie line, the next step is for that line to completely disappear and be replaced by a new tie line that crosses it, tie line flip, reflecting a discontinuous reaction. So the new tie line then typically expands to a new two-phase field as a new continuous reaction takes over. If the compositional range of any single solid solution mineral shrinks to a point, the next step is for that mineral to completely disappear. Ito na yung terminal discontinuous reaction. So, dun lang pinapakita yung upper limit ng stability ng particular mineral. Resolving through three phases defining the subtriangle that surrounds it. Discontinuous reactions control the ultimate stability of minerals. And if bulk compositions are suitably diverse, discontinuous reactions will be the major regional isograd forming reactions, and continuous reactions operate within these zones. Okay? Ayan. So, three types of reactions are used in conjunction. Ito yung in practice, ganito ideally tinitignan yung metamorphic rocks. One, you use a petrogenetic grade to identify complex but useful reactions that are considered major, meaning ito yung main reactions that you should look for. Okay? The pseudosections, however, will show you the mineral changes at a particular rock in a set bulk composition. And then, you use chemographic diagram to follow illustratively yung changes in mineral assemblages across various compositions, but the PT is limited. So each diagram, therefore, has strengths and weaknesses. So the best approach is to, one, keep PT grid as reference, use a set of pseudosections for important bulk compositions, and a series of compatibility diagrams to see how the reactions of different variants affect yung variety ng different rocks. Okay? Yan. So, ganun yung best practice. So, now, let's look at yung further pa. So, tapos na tayo sa storolite zone. Yun na naman medyo magulong part. Now, we move on to the kyanite zone. Sa Barovian series pa rin to. So, medium PT. So, kyanite is introduced around 630 degrees Celsius through the reaction storolite plus chlorite equals kyanite plus biotite. This is a discontinuous reaction that two-phase storolite plus chlorite field shrunk to a single line. In the PT grid, solidus curve for water-saturated granitic composition is crossed also. Ito yon. Yan. Ito yung granite wet solidus. Yan. So, if PT path had been at a higher pressure, take note that if the PT path had been at a higher pressure, the chlorite would be consumed first for the X bulk in question, resulting in storolite garnet biotite rather than storolite chlorite biotite. Ito. Instead of this, storolite chlorite, ito, this daw. Wala nang ganito basically, diretso lang kung higher pressure. Returning to the dash path, further heating enters the storolite biotite field, causes the chlorite storolite biotite triangle to move past X bulk. And so many pellites are of suitable composition for melting to occur, but water may be bound. Since nag-cross na siya nung, okay, yung second bullet, ang point is, since nag-cross na siya nitong granite wet solidus, many pellites are actually of suitable composition for melting to occur, pero water may be bound in the micas and not necessarily available as an intergranular fluid phase. If that is the case, hindi mag-melting yung rocks natin kasi wala namang tubig in the first place. I think this is the wet granite solidus, meaning you have water interstitial. Okay? Melting, however, may still be possible in fluid-absent rocks above the solidus, but the amount of melt generated depends on the amount of water liberated by the dehydration reactions and made available to enter the melt. The free H2O or water content of met rocks can vary from water saturated to nearly dry, and the latter is much more common, so melting rarely occurs at this point due to lack of water. Okay? So for example, dito, kung titignan niyo yung PT pack natin, walang melting na label. So usually kahit sa pseudo sections pinapakita yung melt as L, liquid. Okay? Pero dito, wala. Siyang ganun. So if excess water is available as intergranular fluid, melting begins. If not, melting depends on the amount of water freed during dehydration. Yun yung important. Okay, so sa kyanite zone, so as you can see from here, theoretically, stable lang ulit si kyanite, pero hindi siya nangyayari sa bato natin. Instead, kyanite becomes available to most rocks kapag nag-tie-line flip uli, yung storolite chlorite natin gets eaten by the kyanite biotite stability curve, for example. Yeah. So through this reaction, so storolite plus chlorite equals kyanite plus biotite. This continuous reaction, the two-phase storolite plus chlorite field shrinks to a single tie line and melting, so yun, tie line flip. And then take note na at these temperatures, melting can occur. Okay? Ano pa? Okay, so ito yung kanina, yan. So, storolite chlorite until eventually, kyanite zone, storolite plus chlorite becomes kyanite plus biotite. Above kyanite isograd, chlorite, kyanite, biotite, triangle moves to the right, papunta sa kanan. Due to continuous reaction, chlorite basically keeps breaking down until, in favor of kyanite plus biotite till it's completely, wala na, till it's out. So yan. Dito sa diagram na ulit, as you can see, wala ng chloride. Okay? At this grades, compositional range of chlorine shrinks dramatically with increasing temperature towards pure magnesium end member, and then magnesium-rich chloride disappears in the KFMASH system at the magnesium chloride phlogophyte plus kyanite reaction. Chlorite thus finally disappears from AFM, yielding biotite and kyanite. So ito na yung assemblage natin sa kyanite field. As you can see, much essentially of the rocks are, much of the pelitic rocks are of the same mineral assemblage, which is garnet, kyanite plus biotite. The only ones that lack such assemblage would be the ones na walang very low aluminum. So very low aluminum, dito lang sila sa garnet and biotite. Okay? Kyanite, so itong diagram na to also shows yung storolite out isograd due to the formation ng garnet, biotite, and aluminum silicate in the pseudo section at above 660, 1 GPa. So ito yun. Storolite breakdown to garnet, biotite, and kyanite. Okay? Yan. So storolite out isograd around 660, ito yung reaction. And in the PT grid, kyanite and sillimanite transformation around 0.10, ito. Yan. So polymorph transformation at 0.10, petrographically observed as fibrillite needles on mica. Pakibalikan na lang yung reaction natin, yung lecture on metamorphic reactions. Yung last examples and how the reactions occur, yung kyanite to sillimanite transition. Above the kyanite to sillimanite transition, muscovite and quartz equals alkali feldspar plus silica, plus sillimanite plus water. Ito naman pointing out yung sa ano. Wala na kasi dito, hindi na siya kita dito sa diagram. Pero at lower pressures, mas nag-occur yung reaction earlier. So ganito siya. Muscovite plus quartz equals alkali feldspar plus sillimanite. So this is a conspicuous increase. This is shown as a conspicuous increase in sillimanite, while quartz or muscovite is lost. So usually pag meron ka ng alkali feldspar, usually yun yung doon na pupunta yung K and aluminum na originally ay nasa muscovite. And this time, since breakdown to ng muscovite, the liberated water can cause melting. This usually is equivalent to the amphibolite granulite phase sheath transition. Okay? Okay? Yeah. So, alkali feldspar development makes it less schistose and more gneissic, And two, the AFM diagrams must now be projected from alkali feldspar kasi wala na tayong muscovite. So, mamaya sa diagrams, eto lang naman yung ibig sabihin ng KFS na instead na muscovite. Okay? And syempre, nagbago na rin yung itsura niya, yung projection, since projection na siya from KFS ngayon. Okay. Ito ay for low pressure. So, well, pero theoretically, pwede siya mangyari. Cordierite in isograd. Cordierite in isograd through biotite plus sillimanite equals garnet plus cordierite plus water. Very high grades because biotite sillimanite tie line flipped with new garnet cordierite tie line. I think we'll get you naman to. At ultra high temperature, OPX out through OPX out. No, biotite out to that. Sorry. This is biotite out at UHT condition. So biotite plus quartz equals OPX plus alkali plus feldspar plus water. And in less aluminum-rich rocks, quartz feldspathic rocks. The reduced, in general, yung result nito ay rocks na may reduced large ion lithophile elements, characteristic mineralogy of sapphire plus quartz and or spinel plus quartz or osmiolite and garnet. So this is very common in Precambrian terrains where heat was carried by dry igneous bodies from the mantle to the lower and middle crust. For example, yung mga UHT rocks na alam ko ay nasa Antarctica, inaro yung sensei ko. Kasi nga, the geothermal gradients back then were significantly higher, way higher. Okay? So, effects of non-KFMASH system sa ating stability ng phases. So, effects of non-KFMASH, sodium enters and stabilizes plagioclase and paragonetic white mica. Little calcium sa pilitic rocks can affect garnet, plagioclase, epidote, and zoisite. And margaritic white mica can form garnet, plagioclase, epidote, zoisite, and margaritic white mica. Presence of plage, however, does not radically plagioclase feldspar, so iba siya sa alkali feldspar, does not radically alter KFMASH system. And sabi ni Worley and Powell, 1998, while titanium and iron in pellets had little effect on silicate mineral equilibria. Siguro yung titanium and iron, ano lang to, kung ano yung titanium phase sa makikita niyo. So, usually doon naman napupunta lang sa ilmenite, rutile, or titanite. Okay, manganese however is significant kasi just a little manganese sa bato natin can drastically increase the stability of garnet towards lower grades. So compare niyo for example in garnet in curve, mamaya papakita ko in MN KFMASH versus KFMASH only. Yan. So ito yung garnet in sa manganese KFMASH. Ito naman yung garnet in sa KFMASH lang. So as you can see, the temperature difference is around 150 degrees, essentially. 600, ito mga 500, mga 100 to 150, depende sa pressure. Pero yun, malaki yung, 420 at 0.95 gigapascal versus 520 and 1.5 gigapascal. So, medyo iba. I mean, nagbabago yung itsura ng section. Okay? How about low pressure temperature metamorphism? So, hindi na natin ulitin lahat, pero just the important reactions. So, unlike mafic rocks, pellets, as we've discussed, are pressure sensitive and can be used to distinguish a variety of lower pressure gradients. Reactions in the PT diagram thus occur in closely spaced succession and varying in nature and sequence with slight pressure differences. It's therefore difficult to predict sequence of isograds occurring in nature at lower pressures. However, at low PT pellites at around 440 degrees Celsius, then biotite enters in albite epidote hornfels facies, and this results to generally coarser and randomly oriented than fine phyllosilicates outside the aureole, kasi low PT is of course contact met, and chloritoid may form at slightly higher grades in iron-rich pellites. Iron chloride to biotite plus chloritoid just above 500 degrees Celsius. So what's different? Andalusite and or cordierite is present. So andalusite as an aluminosilicate phase and cordierite being more common sa low pressure phases. Yan. So, ito yun. So, low PT gradient. So, basically here, biotite enters. Ito yung biotite enters kanina. And then, cordierite can theoretically form, pero not in all rocks, as will be shown shortly. And instead, most chloritoids are, uh, and also at the same time, chloritoids can also form if iron-rich naman yung bato at around this period or PT section sa PT space. So ito yung itsura ng AFM diagram. So with increasing temperature, ito yung bato natin. Chloritoid decreases and chloritoid tie line increases. Chlorite, biotite, chloritoid also increases. Yan, so ito. So, move siya papunta sa left, basically. Okay? Saglit lang ha. Okay, I think yung point lang naman nitong dinidiscuss na dito is chlorite and chloritoid will first, yung bato natin, essentially, will be chloritoid plus chloride muna. And then, yung white dot yata is in subsection. So, yun na dun sa kanina. Yan. Yun nandito. Yun nandito sa this one. Okay, so tinanaw natin at low pressure conditions, una chlorite field lang siya. Tapos, most of them are chloritoid and chloride or chloride plus biotite. With rising temperature, lumilit yung chloritoid natin na linya, na line. And lumalaki yung chloride, chloritoid, andalusite na field. Okay? Yan. Tapos, at the same time, yung chloritoid, biotite na field also increases. So, nagmo-move sila papunta dito at saka papunta dito. So, eventually, with increasing temperature, yung chlorite and chloritoid na tie line gets broken. And now we have a new tie line, yung andalusite and biotite. Okay? So, kaya yung reaction. Medyo, as you can see kasi ang problema dito sa low PT, lahat sila nangyayari very quickly. Magkakadikit yung mga diagram, yung curves natin. So, anyway, tinanan natin siya sa AFM. So, yan, so nag-i-increase lang yung triangle na to. So, increase hanggang eventually naputol na siya. So, now yung rocks natin are, yung most iron-rich rocks natin ngayon ay, andalusite, biotite, and chloritoid na yung kanilang field. Ay, actually, since may Thailand pala dito, wala silang chloritoid. Ano lang yan sila? Andalusite, biotite, chloride pala dapat. Yeah. Pero again, this is most obvious on the iron-rich rocks. Okay? And then theoretically, stable ba si chloritoid hanggang dulo? Pero because of the tie line flip, wala na siya. Hindi na siya makikita sa mga bato. And instead, eventually, yung chloride natin, as it continues to shrink in size, eventually it gets run over by the cordierite field. So yung cordierite and biotite and andalusite eventually forms in triangle natin, which we will now see sa bato natin. In other rocks, in most rocks actually, well, in this group, for example, it will always be andalusite biotite. Okay? Yung ibang bato lang, yung magpapakita ng biotite, chlorite, and andalusite, and then eventually chlorite, cordierite, and andalusite. Wala nang chlorite. Biotite, cordierite, and andalusite na mineralogy. So, ganyan yung sequence. Ito. Anyway, I think nasusundan nyo naman to. Take note lang na yung chloritoid ay stable siya all this time. Pero, stable siya all this time. Pero since due to the tie line flip, hindi na siya kita sa mineral natin. Ay, sa bato natin. Okay? So, the final product at Hornblende Hornfels species, rocks are either andalusite biotite or andalusite biotite cordierite or cordierite biotite depending on their magnesium number. Cordierite and andalusite isograds in lower aluminum pellets can occur as a result of multiple continuous or discontinuous reactions depending on bulk composition. In the subsection, around 0.2 to 0.3 GPa, heating causes andalusite to join the chlorite, biotite, before chlorite is lost, and then cordierite joins biotite and andalusite. Yan. Anyway, sundan nyo lang itong field na to. So, una, biotite, ano siya? Biotite andalusite. And then, eventually crosses, heating andalusite, causes andalusite to join dito. To join chloride plus biotite. Okay. Ito. Hindi naman. Medyo, okay. Ito yung minimi niya. Biotite and chloride joined by andalusite na field before chloride is lost, so wala nang chloride, and then you're left with biotite and andalusite. Ito pala yung tinutukoy. Okay. Yan. So, at pressure greater than 0.2 GPa, if pressure over temperature slope is steep, storolite is stable via the chloritoid plus andalusite equals storite plus chloride reaction and can be found in iron-rich pellets only up to 560. Then, garnet stability also depends on the gradient. It may form at the expense of chlorite or chloritoid, more common at low pressure above 650 degrees Celsius due to the reaction of iron cordierite and iron cordierite and anite, or andalusite and biotite near pyroxene form species through this reaction. At greater temperatures, partial melting occurs. Note that the shape of the solidus means that muscovite and biotite may break down first before melting. Dito sa ito. So, ito yung muscovite ano natin ba? Sorry, ito. Yan. So, ito kasi yung granite solidus natin. As you can see from here, at lower pressures, mas mataas yung temperature required. And therefore, by this time, for example, wala na tayong muscovite quartz is transformed na to alkali feldspar. So dito pa lang wala na tayong muscovite. Pero so wala ka na basically ng tubig. So pagdating mo dito, wala na. Wala ng tubig. So paano ka mag-melt? Hindi na siya mag-melt. Okay? Yeah. Okay. So low PT, to summarize, low PT metamorphism of pellites differ from medium PT in the following ways. The reactions of the PT grid are closely spaced and many intersect. In many of these reactions intersect, forming several invariant points. As a result, new mineral isogrids may be tightly grouped and complex, varying significantly with P, T, and X. Cordierite is a common mineral and occurs at low to intermediate grades sa low pressure. And andalusite is a stable aluminosilicate polymorph at low grades, giving way to sillimanite at high grades. Chlorite breaks down at lower grades. Storolite and garnet is less common. Storolite does not occur at all below 0.2 GPa. And high-grade assemblages, orthopyroxene spinel, are more likely to be developed before melting occurs. Okay? Kasi nga wala na tayong tubig. A common sequence of isogrids in contact aureole, low PT, is like this one. Okay? Yeah. So so in general, yung high T setting or high temperature UHT setting rocks are actually best preserved kapag contact metamorphosed or anyway kapag in these low pressure areas kasi wala ng tubig, muscovite out nauna yung muscovite out kaysa sa actual melting. So, ginawa ni Spear, 1999, minodel na yung KFMASH system at higher temperatures, and he found out that sodium is needed to stabilize, he used sodium pala to stabilize albite with the following assumptions. Only H2O available for melting is that derived from dehydration reactions, meaning closed system, walang addition of fluids. In subsolidus region, minute amount of vapor is nearly continuously evolved due to dehydration reactions, but most fluid leaves the rock. Initial melting may thus occur at water-saturated conditions, but its extent is very limited. And once melting begins, any water evolved by dehydration immediately dissolves into the melt phase and remains in the rock as long as the liquid is not removed. Yeah, anyway, these are basically yung assumptions and hindi naman yung interpretations. Tingnan na lang natin yung itsura. So these assumptions reduce yung numerous possible melting reactions to only a few because the only vapor saturated melting reaction that is stable becomes the one at lowest temperature. Fluid flux. So, of course, with melting, there are two ways, fluid absent and fluid present. Fluid absent is kapag dehydration, essentially. Dehydration reaction that produces melt. And fluid present reaction is yung sinabi kanina na breakdown ng some hydrous phases can produce or can supply yung tubig. So, tingnan natin kung sino yung mas effective in causing melting. So dito, for example, muscovite, ito ay classic na muscovite plus albite plus vapor. Yan, so fluid present melting produces aluminosilicate and liquid. Okay? And yan, so ito yun, si A. Sige, next ko na lang muna. Focus here. Yan, para i-discuss natin yung itsura. So si point A, muscovite plus albite plus quartz equals aluminosilicate plus liquid. This is a fluid present reaction. Due to very little available water, however, little melt is generation. So this we can see this met rocks as alkali feldspars in melt segregations. At pressure less than the invariant point, this one, 0.1, muscovite bearing reaction will dehydrate below the solidus. So dito yon, dito yung curve na to basically. Yung curve na to, ito. Yung curve na to, so muscovite bearing rocks pala will dehydrate below the solidus to produce alkali feldspar and aluminosilicate without melting. So ito naman yung AFS rich, alkali feldspar rich na porphyroblasts sa met rocks. So yun yung distinct difference between medium PT and low PT. At point C, major melting reaction occurs. This is fluid absent na melting. So actually, as you can see from here, walang vapor na dinagdag. Pero dehydration ng muscovite produces yung ating, or provides yung fluids which are then used to form melts. Okay, so muscovite plus albite plus quartz equals aluminosilicate plus alkali feldspar plus liquid. Ang basic calculation is PEER. Yung melt volume is equivalent to 70% na muscovite consumed, meaning around 7 to 28% melt ang na-produce during this reaction. So yun actually yung main driver ng melting sa met rocks, sa pelitic rocks. Okay? Liquid along with orthopyroxene and cordierite may be generated by dehydration melting of biotite at 850 degrees Celsius and beyond point B, at low PT, cordierite may be created by univariant reactions and vapor saturated melting occurs at point D, fluid present, but more voluminous melting again still happens later on dun sa fluid absent na curve na to. Okay? At slightly higher PT, initial limited vapor saturated melting may occur by the same reaction, and more melting happens through F, however. Because of these assumptions, because of the assumption na walang external water, this should be treated as minimum melting conditions. Okay? The pseudo section here shows the minimum temperature of liquid, the maximum pressure for cordierite, minimum temperature for liquid, which is this one, liquid, ito, solidus. But this is the effective solidus. Ayan. Ito yung sasabi ko na even pseudo sections show yung melt. So liquid as liquid. And predominance of high variance assemblages, contours show the melt percent. As you can see from here, although ito yung solidus natin, actually, wala masyadong na-form na liquid after. So 0.1 lang. 0.1 moles, x-moles pa. Yung much of the liquid gets produced after liquid and then produces melt. Ito, water produces melt. Pero yung melting happens much later dito pa, yung ibang curves pa. Okay? Garnet, this also shows yung cordierite, maximum pressure for cordierite. Ayan, as you can see, walang cordierite beyond this point. CRD, CRD. Ayan, ito, cordierite. Ito lang yung cordierite curve natin. Ayan, and minimum pressure for garnet ay basically, andito, sa taas lang. Ito lang yung garnet. Okay? Ayan. So, ang ginawa nila next, i-calculate sila ng T melt percent. Nagpakita sila ng T melt percent na diagram. So, this basically shows yung percent ng melt uh, through the different, through a section sa pseudo section. So, pag slicing this one, for example, ganito daw ang itsura ng melt proportion. So, ito yung solidus na cross niya. Amount of melt produced is very little. Once muscovite breaks down, however, melt spikes and then continues. Pagka wala na yung biotite, then dehydration ng biotite, melt proportion also spikes, etc. Okay? So, fluid present melting produces little melt, while melt percent increases with rising temperature due to dehydration reactions. Okay? So this produces yung ating migmatites. Migmatites are dehydrated rocks, and restites becoming dry and depleted. They are usually dry and depleted granulite facies rocks. Many others develop felsic segregations and are called migmatites, or literally meaning mixed rocks. They are mixed dark. They are composed of mixed dark schistose component, the melanosome, intimately associated with light-colored, coarser-grained, centimeter-scale layers, veins, or pods of poorly schistose material or leucosomes. Paleosome or mesosome, this is the domain or regions ng bato, sections ng bato rather, na composition is intermediate between the two. So they could be an affected original rock, or some interpret this as the high volume of melt mixed with the restites. Best developed, this rock type, migmatites, is best developed in metapelites, but is also present in sandy and arcosic sediments, mafics, and granitoids. Yeah, so migmatites are classified structurally on the basis of the relationship between the leucosome and melanosome. So you may have vein type migmatites, so yung D daw, vein type migmatites. You also have stromatic migmatites, E, yan. Nebulites, H, and agmatite, 26A. Yeah. So other common structures are also illustrated sa figures, include net-like structures, B, rafts of material, similar to rafts of material that are similar to agmatite. Yeah. Anyway, these are basically yung textures na makikita natin. Okay? So, paano ba na-form yung migmatites, or ano yung interpretations natin? So, for the origin of the migmatites, multiple theories, basically three. Injection of granitic leucosome into the dark high-grade schistose rock, localized partial melting with the first melt as granitoids, and the melanosomes as the restites. Number 3, created by metamorphic differentiation or metasomatic growth of the leucosome, and melts are not involved. So, in reality though, melanosomes generally are more mafic than pellite. So, while leucosome is more felsic, but the combination of the two is pellitic. So, yun. So, basically, hindi na to yung one based dito sa general observation ngayon na melanosomes generally more mafic than pellite, yes, and the leucosome is more felsic, pero pag pinagdagdag natin, pag inad natin silang dalawa, their average is yung original na bato. So, hindi na pwede tong injection of granitic leucosome into dark high-grade schistose rock. So, it's either of these two na lang. So, localized partial melting, with the darker parts being the restites, yung minelt, and yung leucosomes being the melt. Or, pwede rin siya na metamorphic differentiation. For some time, because of the felsic character ng leucosomes, they were linked to granitoid origin. Leucosomes generally, however, are more tonalytic, and sediments can be molten as low as 650 if with water. So, it was shown that sediments can be molten as low as 650 if with water. So hindi na rin basically yes, some melts are contributed to form granitoids pero definitely hindi. Hindi lang siya through this simple mechanism. Okay? Large scale melting pa rin dapat yung kailangan for formation ng granitoids. Okay, so this, for example, just a diagram from Hollisher showing yung channelization and so ito yung reaction which produces the melt. And so sometimes pwede siyang parang veins lang, others pwede siyang channelized kagaya nito. Basahin na lang yung diagram dyan. Basically, just shows yung migmatization process ng mga patok. Okay, ito yung itsura nila sa thin section. And take note of the alkali feldspars. Yan, pag may alkali feldspar, that's usually the mark ng dehydration ng muscovite and therefore significant melting. In the field, this is how they look like. Yan, yung mga leucosomes versus the melanosomes. Yan. So this one, garnet bearing. Yan, this one. Ito, nakakita ko na before. Yan. So, mukha silang melt segregation, di ba? So, kaya yung, again, because of their characteristics, kaya ito yung, yung interpretations ng una, number 2 at number 3. Okay? Ito yung migmatite. Migmatite. Well, buong yan, migmatite, pero yung leucosome pala. Tapos ito yung mga melanosomes. Yan. So, more pictures. Yan. Sorry, hindi ko natangal. Add more pics from Hollisher. Yun na yun. Ito na yun. Yan. Ito lang kasi yung kay Winter. Yun lang. Okay. So, high PT metamorphism. This is more common in basic rock. So, ito na yung last PT gradient natin. So, medium, low, now high. High PT, more common in basic rocks, but some localities record pelites with high pressure temperature. At low temperature, talc is present, expanded phengite-rich and celadonite-rich muscovite and paragonite, plus the mineral sudowite and carfolite. Talc in most pelites is biotite plus chlorite equals talc plus chloritoid, or talc in most pelites is introduced using biotite, through the reaction pala, biotite plus chlorite equals talc plus chloritoid plus water. So, I think, anyway, hindi ko na-isa-isahin ulit, pero I guess you can see through kung paano nangyayari yung ganito, paano na-introduce si talc. So, yan, dito siya, theoretically stable na si talc dito, pero the triangle increases in shape until eventually, wala nang chloride, nandun na siya, and instead we have biotite chloride, biotite talc chloritoid. Yan. Okay? Eventually, mawawala rin yung talc, yung sinasabi niya, wala rin yung talc. Naging kyanite chloritoid biotite or biotite chloritoid ka na lang. Or garnet chloritoid biotite. Yan. Talc plus phengite, talc plus kyanite, talc plus pyrophyllite, I think to. Plus talc plus magnesium chloritoid assemblages as high pressure metasomatically altered granitic protoliths. Garnet forms earlier though does not occur till garnet chloritoid biotite triangle moves to the right. Okay? Via continuous reaction. And then chlorite is lost to talc plus kyanite. And kyanite is introduced but only in high aluminum pelites. In most samples, it happens when talc chloritoid tylene gives way to biotite kyanite tylene. Yeah. I think you can read this. I mean, you can interpret this na by yourself. Yan. So, ito yung location ng mga reactions na yun sa PT grid. Yan. So, at pressure greater than 2 GPa, talc plus phengite plus, I think this is PY, pyrophyllite at plus kyanite plus silica polymorph develops. Silica polymorph coesite. This is the marker for UHP basically. So UHP rocks are continental. We'll discuss this. Crustal rocks subjected to 100 kilometers without melting. Yeah, that's it. Diba? Sige. So anyway, basically, yung important technique dito is yung makita nyo kung paano represent ang continuous and discontinuous reactions sa AFM diagrams versus pseudosections versus petitiglids. Okay? I think that's it.